Hey everybody, good morning. Well, at least it's morning for me right now. This is the second video, should be quick I hope, for the 5.1 notes and homework. This video is going to give you the first few homework freebies but more important than that, kind of show you how you're going to actually do the homework problems and how to turn them in and whatever. So here's the assignment number 21. There's going to be some instructions here, probably brief, whatever I need to say before I assign it to you, but so this was the big video, just kind of explaining this whole like solving systems by graphing. We're gonna actually almost hit all those major notes again quickly in this video because it's not that complicated, as you probably already know. The notes handout, well, there's going to be like another file here. The video I'm literally making right now is going to be probably right here, right after this first video. And then what you see is the Google Doc, and I don't think I'm going to provide like a hard copy, like a PDF file of this, because I don't think you'll need it. But let me know if you really want like the PDF copy of this. I could make one, but we're just going to need this Google Doc, and this right here is like the best online graphing calculator that I know of. Desmos.com, the Desmos graphing calculator, the best graphing calculator I'm aware of. It does whatever I need it to do, so I've never had any reason to research other ones. So here we go. You open up your Google Doc by clicking it, and look at that. It's beautiful. So here's what you got to do. Is there a way I can get that out of there? Ooh. Identify the solution to each system of equations, or state that there is no solution or infinite solutions. Use the graphing method. So all you're going to do, where the heck was I a second ago? Here. So you're going to open up Desmos graphing calculator. You could Google it or just click on this attachment I have here. And it's wonderful. I hate that. So now what you got to do is we're just going to use the online, like that website, to graph these lines. So y equals negative 1/3 x plus 2. Here we go. So you click here. Y equals negative 1/3 x. Oops. You see what happened to me there? Don't forget about this. I just hit like the / and it automatically made it a fraction, which is nice. And then I hit 3, and look, next is kind of important, I guess. But you're probably savvy enough to have no concerns with this. But right now, you see where my cursor is? I have to hit the right arrow. See what happened? I'll go back again. Oops. So it was here, I hit the right arrow, and now I can hit x. And then I think it was plus 2, right? Negative 1/2 x plus 2. Look at that beautiful line. Negative 1/2 x plus 2. Then what was 2x minus 5? So you got to hit enter so you can put a second graph, okay? So y equals 2x, shoot, I forgot, minus 5. This might be the most annoying part, is clicking back and forth. I don't know. Maybe you can figure out a way where it's not this frustrating, whatever. But so now, gang, all you do is you look at the two lines you have, and if you have to zoom out or zoom in or go find a different spot, but all you're really looking for is where these two lines intersect. And as long as you've clicked on one of the lines or somewhere up here, as long as, like when I click here, everything goes away, but when I click on one of the lines, I can now go on that point. That's one of the best things about Desmos, is it automatically points out, you know, like certain points, like points of noteworthy points, like where they are intersecting at 3, 1. So you go here and you click where you're typing it in, and you just type in 3, comma, wow. So 3, 1, and that's the answer to number 1. And then you just rinse and repeat. So we go number 2. Y equals 4x plus 1. Y equals 4x. Sorry, I just turned on a light. I can't see my own keyboard. That's why I've been making all these mistakes. Y equals 4x plus 1. 8x minus 2y equals negative 2. 8x minus 2y equals negative 2. So just like that, right, I have them both graphed. And I move it over, maybe zoom out, zoom in. If you didn't catch what happened, look, click, 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 click. It's the same exact line. And so remember, what that means is that there is infinite number of solutions to the system. Number 3, y equals negative 2x plus 7. I mean, this is important to understand, so I hope you watched the first video and you understand, you know, this whole deal where, sorry, I don't know if you can hear that garbage truck or recycling truck, I don't know. But it's important to understand this whole situation. Most of the time, you're going to get this one single solution to the system, but this is one of these like special cases where you have an infinite number of solutions. Let's see what happens here. Y equals negative 2x plus 7. Negative 2x plus 7. There's the first line. And then 2x plus y equals negative 3. Stop that. 2x plus y equals negative 3. And check this out. Maybe zoom out. Whoa, that's pretty cool. But these lines are obviously parallel. They're parallel, which means they don't share any points in common. The two, again, so I'm getting a little long-winded here and very thorough, but it's a good thing. So again, the two lines, the graphed lines, they don't share any points in common. In other words, these two equations don't share any solutions in common. They don't cross anywhere. And so that means there is no solution at all to the system when that happens. When the lines are parallel in a system, there is no solution to the system. Okay? Even though that this equation on its own has its own infinite number of solutions, and this equation separately on its own has its own infinite number of solutions. We're talking about the solution to the system of the equations together. And when their two lines are parallel, there is no solution. And then you just have to do the other, I think, 9 questions. So there's 12 questions total. I just did the first 3 for you. That's how you do it. Desmos.com, baby.